Hello and welcome to our project demonstration, which is titled Demonstration of CAN Bus. I am Syed Asim Ahmed and
I am Sean Malbari.
And I'm Zohaib Ahmed.
So our project consists of 4 nodes, 1 sending node and 3 receiving nodes. They are all consisting of Arduino microcontroller with a CAN bus shield, which makes up 1 node. So the node 1 is sending node, which has sensors attached to it, whereas node 2, 3, and 4 are receiving nodes, which have actuators attached to it. These nodes are not connected to each other except through the CAN bus, which is denoted by the red wire, which is the CAN high, and the yellow wire, which is the CAN low.
The node 1, which is the sending node, we have connected the 3 sensors as we have explained earlier. This is the 3-axis accelerometer, which gives you acceleration values in X, Y, and Z domain. As we move this accelerometer, we can see these values being changed on the LCD. This is basically a car which we have modeled, and this accelerometer can detect a crash. So whenever something will hit this, so it will detect a crash, and you can see this on the LCD. So this is the temperature sensor, LM35, which gives temperature values in Fahrenheit on the LCD. So we have put some hot rag on this to increase the temperature, and we can observe the increase in temperature. So according to the algorithm, when this temperature reaches 90 Fahrenheit, this should switch on the fan, so we can focus on the fan and the LCD. So when the temperature reaches 90, the fan should switch on. Now removing the hot rag, we can observe the decrease in temperature, and as the temperature will go down below 90, the fan has switched off. Now coming to the rain sensor, splash some water on it, the wiper should switch on. And the speed of the wiper varies with the water level. So if we put more water, the wiper should go fast, and if I wipe some water out, the speed should slow down. And wiping it completely off. This accelerometer gives values on this phone application, where we can see the X, Y, and Z acceleration values, and these are the same values as we can see on the LCD. This temperature sensor gives values which you can see on the LCD as well as on the phone right here. And whenever there's a crash, this will notify you on the phone and on the LCD. So whenever there's a crash, we can see the crash written on the phone as well as on the LCD. And the buzzer also goes on with the LED light.
On node 3, we have a Bluetooth module and a fan, which is used for cooling purposes of the vehicle. For the fan, we have a special circuit which we have made in custom with transistor, diode, and resistor, because for Arduino it cannot supply the maximum amount of current that is required to turn on the fan. From the Bluetooth module, we have linked the smartphone, and from that we can manually override the fan values. When I'm pressing 1 on it, so it turns on the fan automatically, and when I press 0 from it, it turns off the fan. So this feature is the manual override of the automatic fan control. So on node 4, we have a GSM and GPS module and an LCD. One functionality of this is that whenever the engine turns on, it will send an automatic text, and I will demonstrate it by resetting the GSM module. Here. So it says ignition is on. And the other functionality of this is that whenever the crash happens, like from node 1, I tap the accelerometer, it will display it on LCD, and it will send an automatic text to the smartphone through GSM module that the car has been crashed, along with the latitude and longitude of the location. And it will also display the latitude and longitude on the LCD screen. This communication is all being done from node 1 to all the way till node 4, and everything is interconnected with the CAN bus shield.